So today's lesson is about a thing called a probability distribution. I'm gonna kind of go through these notes in a strange order. First is the second one. A probability distribution is, at its heart, it's just a table that gives the probability of any particular value of a random variable. Right. So, in other words, a probability distribution is always going to look like a table, and I'm going to give you an example of one in just a minute. Right. Before I get to that, I feel like I need to talk about what a random variable is. Now, a random variable, it's a vocabulary term. A random variable, which is almost always denoted by a capital letter, is a quantity that can take on a variety of different values based on some random event. So a random variable could be the number that you get when you roll a die. A random variable could be you roll 2 dice. What's the sum of those two things? A random variable could be, how many marbles do you have to pull out of a bag before you get a red one? Any of those things could be a random variable. Okay, so going back to probability distribution, the most important thing about a probability distribution is that all the probabilities have to add up to 1. Right? So I'm gonna draw a probability distribution down below and then sort of walk you through what it is. In a probability distribution, you're usually going to have like an x here, and then on the bottom they'll write a strange thing: P capital X equals little x. And I want to talk briefly about what that means. This simply says the probability that the big X random variable is little x. And then what they'll do is they'll say, okay, 1, 2, 3, 4, 5, 6. So this thing I'm about to draw below, this probability distribution, I'm going to write out the probability distribution for a fair 6-sided die. Right? So this thing below says, what is the probability that your fair 6-sided die will be equal to x? So what's the probability that you'll roll a 1? Well, if it's a fair 6-sided die, that's going to be 1 out of 6. Right? The next one down says, what's the probability that your random variable will be equal to x, which is now 2? Well, again, it's a fair 6-sided die, so this is 1/6. Right? All of these are going to be 1/6. So we've got all of those. And note, the thing that I said here was that the most important quality of this thing is that all of these probabilities, all of these things have to add up to 1. So that's the idea behind a probability distribution. It's just this chart that sort of tells you for any given value what is the probability of that thing happening. So all of these x's are the actual values, and all of the p of big X equals little x, these are all the probabilities of those things happening. I've got a couple examples for us, so we'll take a look at those next. In this next example, we have a fair coin that's thrown 3 times. The random variable x is the number of heads that's obtained. Right? And we want to write a probability distribution for this random variable. So the one thing I would expect everybody to know is that, that this thing is going to start out as a probability distribution, which means I need to write a table. And, your table should look like this. And the thing that I want you to think about is, so what numbers should go into this table? And you don't need to know the probabilities yet, but like how many columns do you need, what numbers should go here? So pause the video, think about that for a second. Think about this random variable x, think about the number of heads that you can possibly get, and think about how you could fill in the top part of this table. Well, if you flip a coin 3 times, presumably you could get heads 0, once, twice, or 3 times. Those are the total things that can happen. Right. The thing that makes this problem more difficult, the thing that we actually have to do work about, is we have to figure out what is the probability for these different things, right? One way that you could do this problem is you could do a tree diagram to figure out, what happens. You could have heads and tails, and then heads and tails, and heads and tails, and heads, tails, heads, tails, heads, tails, heads, tails. You could sort of figure out for each one of those what happens, and that's definitely one way to do the problem. The other way to do it is to simply list out the sample space. To list out, if you were to flip a coin 3 times, what could happen? We could have heads, heads, heads. We could have heads, heads, tails. We could have heads, tails, heads. Heads, tails, tails, or we could have the same things all starting with tails. Tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. I'm just listing out all the possibilities here. Right? So now this, and if you guys remember from our earlier discussions, this thing here is called our sample space. Right? These are all the things that can possibly happen when you flip a fair coin 3 times. Right? So now let's look at this whole thing and figure out these probabilities. So what is the probability that I end up with 0 heads? Well, that happens once. So in my probability distribution, 1 out of 8. Right? And if you haven't already finished this problem, you should definitely be able to finish this problem by counting now. So pause the video for a minute, make sure you can finish it. Right? What's the probability of obtaining exactly 1 head? Well, that happens here, and here, and here. So that's 3 out of 8. Right. In the next one, the probability of obtaining exactly 2 heads, well, that happens here, and here, and here. That's again 3 out of 8. And in the very last one, the probability of obtaining all 3 heads, that only happens once, so that's 1 out of 8. And that's our probability distribution. Like that's it. We are done writing this probability distribution. The whole point of this is just getting that table. Okay, so I've got one more example. So in this problem, I'm giving you a probability distribution for a biased 6-sided die. A biased 6-sided die, by the way, is a die that is not fair, that doesn't have a 1 out of 6 chance of everything. Right? So in this problem, I want us to find the value of k, and then find the mode of the distribution. And I'll talk about mode at the end of this problem. So first, how are we going to find the value of k? The idea here is, remember that in a probability distribution, all of your probabilities have to add up to 1. Right? So that means that 2k plus 4k plus 8k plus 0.05 plus 0.15 plus 4k minus 0.1, that all has to be equal to 1. Right, so now if I go through and combine like terms, I've got 2k, let's see, that makes 14k, looks like I've got 18k, and then as far as numbers are concerned, this is 0.2 minus 0.1, so plus 0.1 equals 1. If I move things around, I'll end up with 18k equals 0.9, and so in short, k is 0.05. Right? So that's the answer to the first part of the problem, find the value of k. Right? The question then asks us to find the mode of the distribution. And you guys have heard the term mode before. You've heard it in terms of mean, median, and mode. In that context, what does mode mean? Right? Mode is supposed to mean what happens most often, what number happens most frequently. Right? In a probability distribution, the mode is simply the one that has the highest probability. The highest probability. Right? So if I take my value of k and plug it back in, this is 0.1, this is 0.2, 0.4, that one's already 0.25, that one's already 0.15. This one over here is 0.2 minus 0.1, which is 0.1. By the way, I'm getting all of those just by plugging this k value in up here. If you look at all these different probabilities, the one that is largest is 0.4. So what is the mode of the data? The mode of my probability distribution is 3, because that was the thing that had the highest probability. Okay? So that's my introduction to probability distribution. The main thing to take away here, like if I could tell you only one thing here, it would be that your probabilities need to add up to 1. Like that's the important thing about a probability distribution. So I'll see you in the next video.